What's good, everybody? In my video today, I'm going to be talking to you guys about rational expressions. So we're working with fractions that have different denominators and variables, and we're going to figure out how can we add and subtract them. So in our first problem, guys, we know that when we're talking about fractions and they do have the same denominator, all we have to do is combine our numerators. So in this problem, we would subtract to get 6w over 16. And then if possible, we would reduce, aka simplify the fraction, and we would get 3w over 8. But in today's lesson, we're going to focus on expressions where the denominator is not the same. So in our first problem, we have b plus 10 divided by 6. And we are going to subtract 2b minus 1 all over 30. Now, the very first thing for us to realize is that we do not have a common denominator. So that means we're going to have to get one. So when I look at this first fraction, I know that if I multiply 6 by 5, I could get 30 and have a common denominator. So that is what I'm going to do. And if I multiply the denominator by 5, that means I have to multiply the numerator by 5. So let's set this up, right? And matter of fact, we're just going to write it right here. So we're going to multiply both of these by 5. All right. And once we do that, our new expression fraction is going to be 5b plus 50 all over 30. And then we're going to write the remainder of the problem. So at this step, guys, we have a common denominator. So now we're going to be able to add and subtract our like terms, okay? And at this step here, we're just going to have one fraction bar because we now have a common denominator. And a very important rule, I sometimes see students forget. Don't forget that we are subtracting. So the signs for 2b and -1 are going to change. So what does that mean, Mr. Peters? Your boy got you. So we're going to do 5b minus 2b, right? And I know everybody knows that that's just 3b. But here goes the trick. Everybody thinks we're going to be doing 50 minus 1, but guys, remember that is a -1. So 50 minus -1, that turns into an addition problem. And now we're going to have 3b plus 51. So please make sure you guys don't get fooled by that little tiny trick right there. They're trying to throw you off with that double subtraction. All right. So we got the common denominator. We've combined. Mr. Peters, are we done? No, 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 no. We have to check to see if we can simplify. And in this problem, we actually can. So I'm going to start off with my greatest common factor in the numerator. So what that means is I'm going to pull out a 3. And when I pull this 3 out, I'm going to be left with b plus 17 on the inside. And this is all over 30. So now at this step, we're not done yet. We can now look and simplify 3 and 30. And once we simplify 3 and 30, what's inside parentheses will not be affected. So that means our final answer for this problem would be b plus 17 all over 10. All right. So this is a quick example of what we mean when we're trying to add rational expressions with different denominators. And what we're going to do is we're going to go over one more example. So in our second example for today, the problem is going to be y plus 24 all over 5x plus 20. And we're going to add x divided by x plus 4. Now, guys, this one is a little bit trickier, and this is why I wanted to go over it. So we're looking at this now, right? And we're trying to find a common denominator, and it is somewhat hard, isn't it? Yeah, because now we have a variable and a constant, right? in the denominator. So what we're going to do is we're going to focus on the second fraction. And I'm really looking at that second fraction because I'm trying to think to myself, is there any way I could take x plus 4 and transform it? Meaning, can I multiply, distribute a number to x and 4 to get 5x plus 20? And luckily there is. And what we're going to try to do is multiply by 5. So remember, right, and we're going to test it first. So 5 times x is going to give me 5x. And then when we go back and distribute 5 to 4, meaning we multiply, we are going to get 20. So I noticed that, I got a common denominator now, but we cannot forget to now go back and multiply the numerator by the same number we multiplied the denominator. I got 5 on it, y'all boys. All right. So we go back to it, and now we have changed that second fraction so that we have a common denominator. So let's go and let's bring down the first fraction so we could start combining, right? So we have y plus. Oh, I'm sorry, I'm using different variables, guys. My bad. It's supposed to be x. Woo. Sorry about that, everybody. It's supposed to be x. All right, so let's put x plus 24. Very sorry about that mistake. All right. So now we're back at it, and at this step, right, we're gonna clean up the colors. We're gonna go to one color. I'm gonna switch to white. Now what we could do is we're gonna have one denominator, 5x plus 20. And at this step, I'm going to look and see what can I combine in the numerator. And once I add 5x and x, we're going to get 6x plus 24. Now, guys, step one, we checked to see if we had the same denominator. We did not. So what did we do? We came up with a common denominator. Step two, after finding the common denominator, we now added or subtracted our like terms based on what the problem told us. Problem said to add, so we added. Now, step three, is it possible to simplify? What do you guys think? Right? And the answer is yes, yes, yes. What we're going to do is focus on a pulling out a greatest common factor for the numerator and denominator. So what does that mean? So I'm looking at the top part of the fraction, and I want to know, can I divide or pull out a number that goes into both 6 and 24? And the answer is yes, I could do 6. So once I pull out 6, all right, I'm going to have inside parentheses x plus 4. And then we're now going to go down to the denominator and do the same exact thing. So the denominator, I'm going to pull out 5. And when I pull out 5, I'm going to be left with x plus 4 on the bottom. So at this step, you guys are saying, hey, Mr. Peters, our binomial, right? X plus 4, that's a binomial, two terms. I see it in the numerator and the denominator. What does that mean? Does that mean I could cancel them out? You bet your sweet self you can. So we're going to cancel this out, guys. And our answer is just going to be 6 over 5. Okay. So when we're talking about adding rational expressions, guys, with uncommon or different denominators, I should say, this is how you guys would do it through the 3 steps that I taught you. And if you found this video helpful, we're going to ask that you smash the like button for us, subscribe to the channel, and just leave any comments for future videos you guys would like to see, or if you had questions on this video. And before we absolutely get up out of here, December 7th, right? December 7th, 5 p.m. Eastern Standard Time. Please jump onto my YouTube live. We're going to be doing a midterm review where I talk about exponents, equations, inequalities, systems of equations, and much more. Thank you guys for joining me today.